And this was the first question. Which areas contain only metal elements? You just got to remember that everything on this side over here, this section here, is a metal. Okay, you've got non-metals here. You've got non-metals in D and E. The ones that are on the staircase are semi-metal. So sometimes they exhibit metallic behavior, and sometimes they exhibit non-metallic behavior. So with the second question, this was a relative hero. John Newland's. Now, the clue was in the fact that after 7 elements, the boxes repeated themselves, so it points towards Newland's octaves. This was indeed the answer, law of octaves. 1869, this was a question on Mendeleev. And the key decision in Mendeleev's approach that was so important was that he actually listed the elements in the order of atomic weight. What he also did was he left gaps for elements that were undiscovered as well. Here's the next question. You needed to make sure that you spotted the patterns in observation. This is a gentle fizz, and then it starts to fizz rapidly, and then it's there's now a flame and a spark as you go down group 1, the alkali metal. So I was looking for something that was a bit more vigorous on each of the observations. So quickly needed to be really quickly, burnt violently with sparks. That needed to be a little bit more, I dare not say sparky, but a bit more fiery. The flame, the color of the flame, you may not know. So that was fine. Disappears rapidly. That needs to disappear almost instantaneously. And I'm looking for a large explosion. So what you needed to do is you needed to look through these answers, and the answer that I was looking for was answer A. Now, this question is a question that doesn't necessarily appear very well on this video, but this was a question where the outer electron is held. Let's put it this way: the attraction between the outer electron and the nucleus is weaker the further out the electron is from the nucleus. So as there is a lower attraction between the electron on the outer shell and the positive nuclei, that electron can get lost and can get donated to, it would usually be a non-metal atom. So that electron can actually be lost much easily than if that outer electron was higher up. So the reactivity increases as you go down the group because this outer electron is more easily lost the further away it is from the nucleus. So the correct answer for that question was answer C. So for this question, the next question that's on the quiz, this was the multiple choice questions. This was a reactivity series of metals, and what you needed to do is you needed to see which metal was higher than the metal in the actual compound, and the answer to this one was the third one. Magnesium plus lead oxide reacts to form magnesium oxide and lead. That answer was the right answer. Gold is usually found in the ground as a metal, not a compound. The key to the next question was to realize that the quicker the conduction in the metal rod, the faster the wax would melt. So if the wax melted, then the metal ball stuck on with wax would then drop. And that would mean to say that the fastest conductors of heat would actually have the metal ball dropping in the quickest time. So the answer to this question was copper. Now, this was a lovely question next, which was a question based on the gold souks in the UAE. And the one that shows that gold does not react with oxygen in the air is that it stays shiny. Which of these word equations show carbon acting as a reducing agent? Well, this would mean to say that carbon removes oxygen from whatever it is that it's reacting with, and that carbon would gain the oxygen. So some people may have thought that carbon plus oxygen reacting to form carbon dioxide could be seen as carbon acting as a reducing agent, but I then would ask the question, well, what is being left behind. You know, the oxygen, all of the oxygen is actually going onto the carbon dioxide. So there's nothing actually being reduced, so to speak. The clear answer for this one is the first response: carbon plus iron oxide reacts to form carbon dioxide plus iron, which in a roundabout way is what happens in the blast furnace. The next question was the first question actually required written responses. The next question was, what is the name of the element with the symbol capital H? The answer is hydrogen. The question following that is, which region are nonmetals found? It's region 3. That's the answer to that. The regions where you have very reactive metals such as sodium and potassium are in region 1. And finally, in which regions are less reactive metals such as copper and zinc found? That is region 2. The next question after that could have had several different answers, but you mustn't you shouldn't have mentioned strength or hardness, because that was actually in the question itself. So you could have talked about ductility, you could have talked about malleability, you could talk about it being sonorous. You could also even talk about it being shiny. You could talk about it being a very good conductor of heat, a very good conductor of electricity. What was interesting was that the question that was earlier may have given you a little guidance on what to say on copper, it being a good conductor of heat. The next question: when copper metal is heated, it reacts with a gas in the air. What's the chemical name of the product? The answer is, of course, copper oxide. Questions following that question. You need to give the symbols: capital N, little a for sodium, capital C, little l for chlorine, and the formula for a substance is MgS. What is the name of this substance? It was important for you to put magnesium sulfide, not sulfate or sulfite, as your answer. Now, this was a question that kind of looked very, very complicated. There was a lot of reading in this, and 2 pictures, not just one. But the actual question itself was very, very straightforward. Give the symbol for the most reactive metal, shown in this part of the periodic table. So again, you need to know that the very reactive metals are on the left-hand side of the periodic table, and the answer is, of course, K, potassium. The next question, predict the physical state of astatine. So it's a very popular question to be asked at Key Stage 3, whether people know how to interpret melting points and boiling points. A lot of people do find this a little bit tricky and they get stuck on it. So chlorine is a gas, chlorine is a gas. You can see because 20 degrees centigrade, that's higher than the boiling point of chlorine. So chlorine would be a gas. Now bromine would be a liquid because it will have melted, but it would not have boiled. Iodine would be a solid. So the clear answer for this, predict the physical state, is solid for astatine. The next question after this asks you to predict the color. So you can actually see that the color is getting darker and darker. So anything like black or very dark gray would have been an acceptable answer. So next question after this. Use the observations to put the elements bromine, chlorine, and iodine in order of reactivity. I gave you all 6 possible answers. So basically what you needed to do is you needed to see whether there were color changes as soon as chlorine and bromine were added. Now you'll see that there were color changes with chlorine and bromine being added to the iodine. So the iodine is actually at the bottom. Chlorine cannot be discolored by bromine. The color after the addition of bromine solution, which is orange, stays orange. So you need to interpret that piece of information like that. And chlorine will be able to displace bromine from its compounds as well. So the overall answer was chlorine, bromine, and then iodine. What I need to make clear is that where you have this information right at the very beginning, color of salt solution at the start, if it's colorless at the start for sodium bromide and then suddenly changes orange, even after you've added a greenish yellow chlorine, that means that a reaction has taken place. And of course, there would be no reaction with a bromine solution being added to sodium bromide. There's nothing to displace, so that's the reason why that stays orange. Now, what is interesting is that if bromine water was to react with sodium chloride, the orange color would actually disappear because the bromine would disappear. There would be nothing to give that orange color at all. So you could assume that the sodium chloride in this particular situation would be in excess. And of course, the dark brown colors that you get from sodium iodide is from the fact that iodine is produced. So in answer to the question, the solution of iodine, which is dark brown, is added to a solution of sodium bromide. We know that iodine is very low in the reactivity series of halogens that we've just come together and put together rather above. So you've got chlorine at the top, highest reactivity. You've got bromine, then you've got iodine. So if you have iodine added to sodium bromide, you're not going to get a displacement reaction. So it's going to stay dark brown. The next question, part of the reactivity series of metals shown below, which two metals would react with aluminium nitrate? Well, those two metals would actually have to be above aluminium. So the two ones that you should select are calcium and potassium from the list. Now, in the next question, there's a lot of information that you needed to lift from this table. So table skills were what was being tested. Immediately, you can see that platinum has no reactions with either cold water or acid. So that would be at the bottom. The one that's the most violent in terms of reactivity would be potassium. So potassium should be on the left-hand side of your answers, the most reactive. Platinum should be on the right-hand side. And then you've got the difference between zinc and nickel. That means, and you've got bubbles of gas as opposed to a few bubbles of gas. So zinc would be the second most reactive, and finally nickel would be the third most reactive. So your final order would be potassium, zinc, nickel, platinum. Several answers could be given. The most popular answer for given name of another metal not in the table, which reacts in a similar way to potassium, was sodium. What gas is formed when potassium reacts with water? The answer is hydrogen. That comes down to the word equations that you needed to revise, the word equations that I gave to you in your revision. Next question, Hassan doing a displacement reaction. Why is this reaction called a displacement reaction? The reason is that you have zinc, which is a more reactive metal, displacing copper, which is a less reactive metal, from its compound. So there's different ways that you can actually say this. You could say zinc replaces the copper. That would be an acceptable way of summarizing it too. The next part was actually a slightly trickier part because you've not only got the reactivity series, you've got some information that comes to you that you need to interpret, and you've also got a data chart, and you needed to find the differences between the highest temperature reached and the temperature at the start, and that wasn't always starting from 20 degrees centigrade. So with iron's temperature at the start, it was much higher, so you actually needed to do this. You to do the subtractions as well. Now, in actual fact, this question was made much easier for you because the rise in temperature was given to you, and that was on the right-hand side. Why was the highest rise in temperature obtained with magnesium and copper sulfate? The answer I was looking for was that magnesium and copper sulfate are actually very, very far apart from each other in the reactivity series. So if you've got metals which are similar in reactivity, the difference in the temperature is much smaller because they're very similar. If you've actually got a big difference between reactivity, you find that the temperature difference is much greater. And the way to think about that is, well, if they were actually the same reactivity, you would have no reaction. If they were similar in reactivity, you would get a small amount of reactivity, and that would correspond to a small temperature change. You've got a big difference, big differences in temperature changes because you have more reactions taking place in that time. More reactions taking place in that time because as the first one kicks off, you've got a large jump in temperature. That then warms up the solution even further, and that then speeds up the reaction. It increases the reaction rate. Of course, let's make it clear that the energy that's released in each of these reactions may not necessarily be the same as well, but a large amount of energy is released into the surroundings when you have a large difference in the position of the metals in the reactivity series. So that should answer the next question as well. Why was the rise in temperature obtained with zinc and copper sulfate not much higher? The reason why is because they're very, similar in reactivity. So you look at that, and basically you would expect a very small amount of energy to be released through these exothermic reactions. So you wouldn't get that spin as time passes of temperature shooting up. So next question, so long as the metal is above the other metal that's in the compound in the reactivity series, you will actually get a rise in temperature. So magnesium is higher than iron in the reactivity series of metals. We just needed to look back at the reactivity series that was given. So the right answer was the fourth selection. All right, the next question is actually, I actually like this question. I really did, because it made you think. The clue was in the formulas. The question was asking what name is given to the extraction of a metal from its oxide in this type of chemical reaction. What you may have thought was that all three of these are different: aluminium, silicon, and carbon. You would not have seen aluminium react this way in our course. However, the aluminium, silicon, and carbon are all acting in the same way. They are removing the oxygen from the chromium oxides. So if they're removing oxygen, that means that they're reducing agents, and therefore this type of reaction is a reduction reaction. And I really like this question. I also had great fun finding a really good picture. This is actually a picture of chromium as well. It's beautiful, shiny metal. And that's it. That was the end of year assessment.